Langchain Upstage Tools Groundedness Check Upstage Groundedness Check Input. A tool that checks if the output of a language model is grounded in the provided context. Groundedness refers to the alignment of the generated text with the given context. This tool is particularly relevant for ensuring the accuracy and reliability of language model outputs, especially when used in applications where factual correctness is crucial. Inputs: the text generated by the language model which needs to be checked for groundedness. This could be a summary of a document, a response to a question, or any other type of text output from the language model. The context against which the input text is to be compared. This context could be a document, a set of facts, or any other source of information that the language model was supposed to draw upon when generating the text. Outputs: a Boolean value that indicates whether the input text is grounded in the context. True indicates that the input text is supported by the context, while false suggests that the input text contains information that is not found in the context or misrepresents the information in the context. Steps: the tool first extracts key phrases from the input text. These phrases are typically the most informative and salient parts of the generated text, such as named entities, key concepts, or important details. These extracted key phrases are then compared to the context. The comparison process involves searching for the key phrases within the context and identifying any matches or close variations. Based on the comparison results, the tool determines whether the key phrases are supported by the context. If all or most of the key phrases are found within the context, the input text is considered grounded. However, if the key phrases are not found in the context or if there is a significant mismatch between the input text and the context, the input text is considered ungrounded. Prerequisites: a language model capable of understanding and comparing text. This language model should be able to process both the input text and the context and identify similarities and differences between them. A powerful language model developed by OpenAI. It can understand and generate human-like text and has been trained on a vast dataset of text and code. A large language model developed by Google. It can engage in conversations, generate different creative text formats, and answer your questions in an informative way. Fine-tune parameters. The threshold for determining groundedness. This parameter defines the level of overlap between the input text and the context that is required for the input text to be considered grounded. A higher threshold indicates a stricter requirement for groundedness, while a lower threshold allows for more flexibility. Challenges and fixes. If the context is too short or does not contain the necessary information, the tool may not be able to accurately assess the groundedness of the input text. Provide a more comprehensive context that fully covers the information relevant to the input text. This could involve including additional documents, expanding on existing information, or providing more background context. If the language model misinterprets the input text or context, it may incorrectly determine the groundedness of the input text. Fine-tune the language model on a dataset of grounded text. This dataset should include examples of text outputs that are accurately grounded in their respective contexts. By training the language model on this dataset, it can learn to better identify the relationship between input text and context and improve its ability to correctly assess groundedness. Description of Upstage Groundedness Check Input Tool in LangChain Upstage. The voyageai embeddings is a LangChain component that allows you to generate text embeddings using voyageai's embedding application programming interface API. It enables you to transform text into numerical representations that capture the semantic meaning of the text, which can then be used for various natural language processing tasks, such as similarity search, question answering, and text classification. Inputs. This input is the text that you want to embed. You can provide a single text string or a list of text strings to be embedded. For example, you might provide a document, a sentence, or a paragraph of text as input to the voyageai embeddings component. Outputs. The output of the voyageai embeddings component is a list of embedding vectors, where each embedding vector corresponds to the input text. Embedding vectors are numerical representations of the input text, capturing the semantic meaning of the text. They can be used for various downstream tasks, such as finding similar text, answering questions, and classifying text. Steps. The first step in using voyageai embeddings is to initialize the component. This involves providing the necessary configuration parameters, such as the voyageai API key in the embedding model to use. After initializing the voyageai embeddings component, you can call the embed documents method to generate embeddings for your input text. The embed documents method takes the input text as an argument and returns a list of embedding vectors. Prerequisites. A voyageai API key is required to access voyageai's embedding API. You can obtain a valid API key by signing up for a voyageai account. The API key provides authentication and authorization to access the voyageai API. The voyageai API key is a unique identifier that allows the voyageai embeddings component to access voyageai's embedding API. To use the voyageai embeddings component, you need to have Python version 3.7 or later installed on your system, along with the langchain library. The langchain library provides the framework for integrating various components, including voyageai embeddings. You can install langchain using the pip package manager. Pip is a package manager for Python that enables you to easily install and manage Python packages, including langchain. Fine-tune parameters. The model name parameter specifies the name of the embedding model to use. voyageai offers a range of embedding models with varying capabilities and performance characteristics. The embedding dimension parameter specifies the dimensionality of the embedding vectors. The embedding dimension determines the number of features used to represent the input text. Choosing the appropriate embedding dimension can affect the performance of the embedding model. Challenges and fixes. If you are unable to connect to the voyageai API, check your internet connectivity. Ensure that your device has a stable internet connection and that the voyageai API server is reachable. Internet connectivity is essential for communicating with the voyageai API, which is hosted online. If there is an issue with your internet connection, you might not be able to connect to the voyageai API. If you encounter an invalid voyageai API key error, ensure that you have obtained a valid API key from the voyageai website. The API key is a unique identifier that authorizes your access to the voyageai API. The voyageai website is the official source for obtaining valid API keys. If you have obtained an invalid API key, it might be due to an error during the key generation process or a mismatch in the API key and your account credentials. Voyageai embeddings. None. Embeddings are numerical representations of text. These representations capture the semantic meaning of text data and allow for tasks like text similarity comparison and clustering. Inputs. Text is the input to the embedding process. This input can be a single word, a sentence, or a larger piece of text. such as a document or an article. Outputs. List of floats is the output of the embedding process. This output is a vector of numbers, where each number represents a dimension in the embedding space. The length of the vector, the number of dimensions, depends on the chosen embedding model. Steps. Encode text into vectors is the core process of voyageai embeddings. This involves using the voyageai API to transform the input text into a numerical representation. The API utilizes a pre-trained model that has learned to encode text into meaningful vectors. Prerequisites. voyageai API key is a crucial requirement for using voyageai embeddings. This key authenticates your requests to the voyageai API and allows you to access their embedding. Services. You need to obtain an API key from voyageai to use their service. Your API key refers to the specific API key assigned to you by voyageai. This is a unique identifier that grants you access to their services and allows them to track your usage. Fine-tune parameters. None indicates that voyageai embeddings does not offer any specific parameters for fine-tuning embedding process. This means you use the model as provided by voyageai without any customization. Challenges and fixes. API key not found indicates that the voyageai API could not locate the provided API key. This might happen if the key is incorrect or if it has been deactivated. Make sure to set the API key correctly means verifying that the API key you provided is valid and correctly entered. You need to confirm that the key is present in your configuration and that it is typed without errors. Invalid API key indicates that the voyageai API found your key but determined that it is not valid. This might happen if the key has expired or if it does not have the necessary permissions to access the embedding service. Ensure the API key is valid means checking if the key is still active, has not been revoked, and has the appropriate permissions for using the embedding service. Rate limiting occurs when the voyageai API limits the number of requests you can make within a specific time frame. This is a common practice to prevent abuse and ensure the API's stability. Implement a rate limiter means putting in place a mechanism to control the frequency of your requests to the voyageai API. This can be done by adding delays between requests or by using a queue to buffer requests. By managing your request rate, you avoid hitting the API's rate limit and ensure uninterrupted service. Langchain upstage tools groundedness check. Upstage groundedness check. Check if the output of a language model is grounded in the provided context. This tool is helpful to determine the faithfulness of the generated output by a language model. For example, if a language model is summarizing a document, this tool can be used to check if the summary is based on the original document. Inputs. The output of a language model. This is the text that the language model has generated. For example, it could be a summary, a translation, or a creative writing piece. The context that was used to generate the output. This is the text that the language model was given as input. For example, it could be a document, a website, or a conversation. Outputs. A Boolean value indicating whether the output is grounded in the context. This is a value of true or false that indicates if the output is supported by the context. A list of supporting evidence from the context. This is a list of text snippets from the context that support the output. Steps. 1. Tokenize the output and context. This step breaks down the text into individual words or punctuation marks. 2. Find all the tokens in the output that are also in the context. This step identifies the words or punctuation marks that appear in both the output and the context. 3. If all tokens in the output are also in the context, the output is grounded. This means that all of the words and punctuation marks in the output are also found in the context. 4. If some tokens in the output are not in the context, the output is not grounded. This means that the output contains words or punctuation marks that are not found in the context. 5. Return the Boolean value and the list of supporting evidence. This step returns a value indicating if the output is grounded, as well as a list of text snippets that support the output. Prerequisites. The context should be a list of strings, where each string is a sentence or paragraph. This is a requirement of the tool, and it ensures that the context is properly formatted. The output should be a string. This is another requirement of the tool, and it ensures that the output is properly formatted. Fine-tune parameters. None. This indicates that the tool does not have any parameters that can be tuned to improve its performance. Challenges and fixes. Challenge 1. The output might contain words that are not in the context. For example, if the context is about a specific topic, the output might contain words that are not related to that topic. Fixes to challenge 1. Use a more comprehensive context or a more accurate language model. A more comprehensive context would include more information related to the topic, which would make it more likely that the output is grounded. A more accurate language model would be less likely to generate output that is not supported by the context. Challenge 2. The output might be paraphrased from the context. This means that the output might use different words to express the same idea as the context. Fixes to challenge 2. Use a more sophisticated grounding check algorithm that can detect paraphrases. This algorithm would need to be able to understand the meaning of the text and identify whether the output is a paraphrase of the context.